Hello, everyone. Welcome to our Oracle AI database series that will be taking place every Monday at 10 a.m. First of the month, Pacific Standard Time, unless it falls on a public holiday. In this session, you'll learn how to build applications that use both relational structure and JSON flexibility without switching databases or rewriting code. Now, I would like to introduce Herman Baer and JP Dix as our main presenters. Over to you, Herman and JP.
And as Ernesto said, you have the pleasure. Next slide, Herman. You have the pleasure of having both Herman and myself talking about JSON and all things JSON, as well as how we mix that in relational. You can see our shiny faces on the slide, but also on the webinar. And so let's go next, Herman. And so let's talk a little bit about what we are going to talk for the next hour or so, or 50 minutes. As we all move into a world that really is dominated and will run on AI technologies, we want to quickly sketch a bit of the problem statement here. We see a lot of our customers fragmenting their data, and we want to kind of highlight a little bit as to why that is potentially a problem. We'll also talk then, of course, on how can we solve this, right? What should we be doing, specifically in the document database space? What should we be doing to not fall into this trap of fragmenting our data? And then we'll wrap up. So let's talk a little bit on the next slide about the problem of multiple databases for AI, right? Why is this a problem? Now, Herman and I both kind of grew up and live in data and database land. And so we often say, like, well, obviously you put this in one data platform, right? Because that's kind of what makes sense if you look at it from the data angle. Before this venture at Oracle, I spent some time outside of the Oracle wall. And the one thing I think you see if you're actively engaged in solving business problems is that you see applications driving data. Where we often take the platform view and say, well, you build a platform and then you put those applications on top of that. The way the world often kind of works is that applications drive what is going on. And the reason for that is that applications often are built to solve business problems, right? And that's what everybody is doing. And so you see these applications being built kind of everywhere, they pop up. And you also see this pressure, right? AI isn't just this big benefit at the end of the application, but you also see that that teams are being pushed to develop ever faster, right? You can do much, much more because AI will help you drive all of these things. We're agile, so let's go, right? And so you see this pressure from the business, from how we do things to build these applications. And so we really are on this quest to deliver these things very quickly. And so what happens if you switch to the next slide and just build it, Herman, until you see catalog? What you really start to see happen, and this is just fast forwarding this slide, is that because we need to go fast, we have this tendency of picking our technology stack for that purpose only. And who's to blame, right? It makes perfect sense. I need to deliver an application. Let's go fast. Oh, the easiest way to do this in like a stack with like things like Node.js and things like that is to put data into JSON documents. And so then the next logical step is, oh, you know what? I'll pick a document database somewhere. Sometimes they're open source, sometimes they're paid for, but they're very easy to get started. And so this app gets built, but then it really starts to kick in, right? Getting to this MVP app is like whatever, a couple of weeks, let's say 2 months. Then you give it to your business users and they go like, hold on a second, I don't understand all these codes. I don't understand, like student IDs make no sense to me. I only know names, right? And this spaghetti that you see on the screen starts forming very quickly. First, we'll add reference data to translate codes into names and all of those wonderful things. Then somebody says, ooh, but I need to report on this. And here's your Excel dump. Then somebody says, oh, but like, I really want to add this other data to it, and I want this to it. And by the way, please dump my data to Excel. I need a bit of a dashboard, right? And so you see this whole spaghetti very quickly happening. And all of these are different platforms, different places where data is stored, different technologies. All of this is going on. And this is just one app, right? We started with a tiny app. It did a bunch of stuff. It solved the problem, and it spins out of control, basically. Now, in an AI world, everybody also wants to know, what does this data mean? And should I use it, or can I use it, and all of those things. And of course, nobody ever catalogs anything. Like, my developers never were a big favorite of like writing stuff into a catalog. But this is kind of what really happens if you don't think about platforms, but just think about applications and let them grow as they so desire. And so if you go next slide, Herman. And so this was a problem before we kind of jumped onto the AI bandwagon. It's an even bigger problem now. And it really is about, well, we're going fast, like that's what we do, that's what Silicon Valley says, right? So this illusion of speed and focus kind of divorces us from what the company or the business actually needs long term, right? And what happens is we don't get this speed. What actually happens is that we start to focus on integrating. We're moving data, we're translating data, jobs break, right? Stuff doesn't get refreshed. What's going on? And what started as a good idea, let's build this app, let's get it done quickly, let's get our business going, becomes this quagmire of integration, stuff breaking, and all of a sudden we spend 80% of our time maintaining all of these little arrows you see in that picture there, right? And so our data platform doesn't actually work for what we want next, which is that AI roadmap. And so now what sounded like a good idea becomes a competitive problem. And it kind of stops us going where we need to go, which is deliver value from AI. Now we have a solution to that, which is on the next slide. And it starts off with, let's think about our data platform. And let's think about what really happens, which we just walked through, right? And so how about we actually go look for a data platform that supports my AI roadmap, but also makes life a lot simpler. And I don't spend all of that time on integration. And so we believe that with Oracle AI Database, we can give you the foundation to consolidate and to develop for AI. We take off the integration requirements. You don't have those anymore, right? You basically work in a singular platform that stores and enables and manages all of these things. So you don't have to integrate 75 technologies and data flows and all of that. You reduce your operational cost and management efforts, et cetera, because you have a single platform. You don't have to learn 75 of them. And then what I think is really important in the AI space is that you have a single data platform to govern, right? You do security, you do access privileges, you do all the governance rules, all of the masking for this type and encrypting for that type on a singular platform that, by the way, actually supports all of this, right? And so this is what we're proposing, right? Let's not get caught into this. Let's build apps quickly and forget about the data. Let's actually think about our platform and then enable apps to be built very quickly. So if you go next slide, Herman. Now, what we're basically saying is that why don't you use Oracle AI Database as your document store? And of course, that requires us to have a good document store. So let's talk about that. And if you go next slide. The first thing we did, it's probably like 10, 12 years ago, when we looked at XML before that, and then we started to see the JSON kind of value add. The first thing Oracle said to build a good document database is let's actually make this native to the AI database, right? And let's make this native to the standards we have. Let's say SQL JSON, right? So we added it into that. So you have all of these rich SQL constructs that now work on documents. We also said, well, we can't just store this as a blob, right? We really need to store this for efficiency, for fast writes, for good reads, like all of these things. And so we built this native JSON data type. Now, we didn't stop there, right? Those were the first kind of really important steps we took. But then we said, no, 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 no. We need to become as good as any document database out there. And so we natively need to think about collections. We natively need to think about how we store these things and then give you a good API to that. And we'll talk more about that. And then again, we said, but hold on a second. Why would I have to choose, right? Why would I have to choose document or relational? And so we'll talk about a paradigm shift. We'll go into around you can actually have both of those. You can have some of the canonical form, but then you can expose it as documents. You can update the document, but you can also update the SQL side. So you have all of that, right? And so we spent 10 plus years making Oracle AI database into a native document database. And so let's talk a little bit about that in the next slide. So this is not document, this is relational, but just a level set on everybody, right? There's a big value to the relational model. There's downsides, people will say, but there's something really interesting going on here. You have this canonical form, right, that everybody is using in a lot of kind of various applications. But let's also talk about it contains rows, right? These things are flat. These things are also structured, right? You can't just say, like, I'm just going to add a bunch of random stuff to it, right? That breaks the structure. But then it also has this whole wonderful relational stuff, right? Where relationships are modeled, you can change relationships, you can add relationships, and that's all broken up into tables. And so there's this core value to this model that we believe is genuinely important, and we want to keep that. And so as I said on that previous slide, then we started adding JSON into this. And so for the next slide, you get to see some of the tricks we played on that. And this is all, by the way, ISO standard, right? So you'll see most relational databases follow Oracle's lead on how we do JSON and mix that into relational. So one way to do this is, hey, I have a table and I have this kind of expansion field, right? It's called data in this table here. It's of type JSON. And then you see this curly bracket stuff at the bottom that we just push into that. And so now you can mix and match. Imagine you have a relational application, but you need to kind of be more flexible. And so SQL JSON allows you, enables you to store all of this as you see here. Then if we go to the next slide, you start to see us do all of the SQL enablement on top of that. So I have relational columns. Of course, I can select from those, but I have this JSON document in there. And what we then enabled is said, you know what? You can, for example, unnest, right? This JSON document has an array, it has a bunch of actors. Oh, can you please kind of flatten those and report those in a relational structure? Or you know what? I want to do analytics on some of that. And so I can do aggregation, I can do construction, I can do all of those things directly on that JSON data that we squirreled away in this relational table, right? And so you have all this power, but it's not a document database yet. No, just keep on that, stay on that slide. It's not a document database yet, right? Because document databases don't organize themselves into tables, right? They organize themselves into what's called a collection. And so a collection is, and if you relate to the relational world, it's kind of like, think of it almost as a table, right? But a collection basically is identified by a name in a namespace. And then it accepts any JSON document. I'll talk about JSON schema in a sec. And so this gives you this kind of data first, schema later approach, right? You have these documents evolve or change or whatnot, but they all go into the movies bucket, which is the collection. Now, if you want structure, if you want to kind of say, no, 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 but it can't be just Wild West, right? Because how am I ever going to understand any of this? You can actually add something called JSON schema. And then you start to govern kind of these documents much more closer, much more tightly. Now, each JSON document inside of a collection always has an identifier. It's underscore ID is what the field is labeled as and is called. And that gives you a lot of the kind of, if you think relational primary key things, right? I want a document with ID, blah, and it'll just fish that out instantly. And the interesting bit of this, right, which I think is what we all need to remember is why people actually want to use this, is that document with ID blah is just fished out in one go and just surfaced in the application. It doesn't do joins. It's basically a fully constructed thing that will end up in your application. And that makes for very simple APIs. And I don't mean simple in like silly or stupid, or it's really simple, right? You just take a get of a document and it populates exactly what you need in your application. And it has all the data and it's all appropriate and correct and all of that. No joins required for retrieval. And so it lends itself really well for that application development pattern that we kind of didn't like. And so that's why people really want to use this type of model and this type of API. And so if you go next slide. So we said, okay, it's cool to add JSON documents into tables, and it's cool to have all the SQL bits. But we want to be a document database, and we want to be able for you to have us as a data platform and then build these apps on it seamlessly. And so we actually created JSON collection tables, views, as well as duality views. And I'll talk more about all three of them in the next slide, but let's stay on this one for a sec. And what we did is, in Oracle, you can now say create JSON collection table. There are no columns, there are no rows, right? If you think of it conceptually, there is just JSON. It's a collection, and you can just store documents in it natively. Now, here's just a SQL interface because it's kind of fun. You can also just use SQL to insert a JSON document into that. As you see on the screen here, you can still select from it. So while we went a document store implementation, we did not lose all of the SQL. But we do have SODA, which stands for Simple Oracle Document API, as well as we support the Oracle AI Database API for MongoDB, and we'll talk more about that later. So you get the best of both worlds. And if we go to the next slide, we kind of said we need multiple use cases to support these collections. The first one we just talked about, right? The collection table. It is an object. It's backed by an open source format that Oracle invented and created called OSON, and it's very optimized for these data collections, right? And so this is really a document store if you think of it like that. But people in Oracle often have relational data. And so we also have something called a collection view, which enables you to run the APIs in read-only mode. And so now you have defined by SQL, it's relational data, but I have a collection get interface on top of it. But as I said, we shifted the paradigm, and we'll talk about duality view a lot more. But that enables you to define something in SQL, to read write through both APIs, whether you want to insert via SQL, whether you want to put via the Mongo API, whether you want to put via SODA, all of that works, right? And so this is basically our document database. And if you go to the next slide, we now give you the choice on how to store data, on how to access data, which client you want to use, which language framework you want to use, right? Do you want to use Spring with a Mongo Java driver or client or Mongo or something, right? All of these are fully enabled. And for those of you who said yes on we are using MongoDB, the next slide Herman's going to go to now is going to be very interesting. Because of all of these capabilities, and because we actually support something we call the Oracle AI Database API for MongoDB, we enable you to consolidate your platform. So if you start out with a couple of Mongo systems and now you go, I keep on moving this data back and forth, we enable you to move your Mongo database, export from Mongo, import into Oracle, connect to the Oracle AI database, and then you basically use your existing Mongo tools to manage your data. Your app mostly works, and off you go. Now you've consolidated your platform. And if you hit next, Herman, we then instantly, without you having to integrate things, with you having to do kind of data movement, we instantly enable you to have SQL we have AI, we have all of these capabilities on top of that. And then again, specifically for those who use Mongo on the next slide, we also support aggregation pipelines. We support a whole ton of advanced Mongo capabilities. We enable you to mix and match that with SQL as well as external data, right? And so we have this entire estate that enables you to move from Mongo to Oracle, or enables you to use the same API. But key to this is that we have this entire database that you can use as a document store. And Herman's going to show you how this actually works live.
Correct. So now it's my job to actually prove JP right. And I'm going to just show you the things that JP was talking about live using an Oracle database. I'm using actually just, a little teaser here. So I'm using my own personal free Oracle Cloud account. You see here, that's the hbearussoho.com, which does not have anything to do with Oracle, to actually show you everything today running in an autonomous database. And the first thing what I'm going to do is, let me just connect to the database that I have set up here in the cloud. So this is Oracle Database Actions. That gives me actually a web-based access to the system. And you see I'm in this user JSON, which has a couple of tables already, but let's not worry about that and start off with what JP was talking about, just creating what I would call a hybrid table, in a sense that you see, let me make it a little bigger, that it has a JSON field and it has some other arbitrary fields, in that case an ID. It could be other relational things, but this is an Oracle table. And if you do a describe on movies, you will see it has the JSON column right next to the other column. And now, still in the relational world, I'm actually working with this table just like I would work with any other table. The only thing here is, since I'm having the JSON data type, you have to insert valid JSON in this column. Otherwise, you would get a nice friendly Oracle error message that this is not a JSON document, what you're doing. And I'm inserting 3 documents here into that table. And now I'm just selecting from it, just like I would do from any other Oracle table in the Oracle database. And you get back these 2 columns. You see, one is the numeric ID and the other one is the JSON data, right? Which is stored, as JP said, in Oracle's optimized binary format for JSON called OSAN. Now that we have this in the table, obviously not only doing a select star, but we can actually select from these tables, either using the SQL JSON operators, which are ANSI SQL standard, or something that Oracle has introduced, which is the so-called simple dot notation, which means that in that case, in the table T, in the column data, you see below here, I'm traversing into the attribute genre, right? And with that syntax, plus, a filter on one of these things, you're actually getting the data returned as a relational result, making it readily available to being used in any kind of, for example, BI tools. You can build views on top of that to relationalize information. You can use the JSON data guys to actually create these views for you. But even at that point in time where we have a table that has a mixed structure out of normal classical data types and a JSON column, there's the full transparency between, the classical relational world and the schema flexibility that you get from JSON. And there's quite a number of applications out there, internal as external, that use these kind of capabilities. So we have customers, you can think of it, this has a high adoption in any kind of industry where the schema model, if you were to model it fully relationally, is 80% probably common, and then, has 20% divergence. Examples would be in the insurance industry, right? So we have large customers in the insurance business where you can think that obviously, home policy is slightly different than an auto policy, but it still has 80% of the same aggregates. And with these kind of technologies, you have the capability of, just combining both in a simple schema using both relational and JSON information. But let's now go over, actually, I could have done it by hand, but now let's create a table, a JSON collection table that JP was talking about. And the big difference here is that a JSON collection table is, as you have seen on JP's slides, all you're doing is creating a collection, which is the physical container for JSON documents. That's about it. There's nothing else that you can store in that table at that point in time. It is really the underlying foundation for native JSON collections in an Oracle database. So you see, I've created it without any column definition. It automatically gets the main column data created, which has the information about the JSON documents. And now I'm inserting, at that point in time, still in the SQL world, I'm just inserting a document into this movies collection. It works just like it worked before. And when you now select from it, you will see one difference. Actually, JP had it on his slide, a difference between having JSON as a generic column in a hybrid table versus a JSON collection table. You have seen, and let me just get the command back. I deleted it too fast. So this was my insert. And when you compare the insert with what you see being collected, you see that you did not provide an underscore ID field as part of this document. So the database automatically generated this column for you, or attribute, to use the JSON lingo. And with the creation of such a JSON collection table, we made this construct, this JSON collection, automatically available and usable within the Mongo ecosystem. Let me just pick the Mongo ecosystem. And I'm connecting to the same free database with the user JSON at that point in time. And you will see that the movies collection that we just created is automatically visible here, right? And it's not only visible, right, if the movie wouldn't be up, but it would be down. We just actually changed that. And if you were to go back, you see, we just have colloquially changed the direction of our movie from up to down, right? So this is the thing, how the interchangeably, and the fact that it doesn't matter whether it's a collection or a relational table, doesn't matter, right? And as we have done it before, we could do m.data. Let's just do genre. And you see, even if it's a JSON collection, you just extract, specific attributes as a collection. You see, there's other collection that I just want to quickly show you. There is actually I pre-built a model that resembles a conference with attendees, scheduled sessions, and speakers, which we will talk later about. But you see, there's other collections that we will touch on later. We have attendees, we have speakers, and all of this is, transparently and interchangeably usable in both of the worlds of a relational view, or, using a simplified document interface. And just, before I'm wrapping up and handing it back to JP, let's quickly actually do the same with another Mongo tool. We would have the Mongo shell here. You will see the same collections here, and the same So you have the full interchangeability. And at that point in time, I think it's important that the Mongo tools don't know that they're actually talking to an Oracle database, right? So you're using Mongo SDKs, you're using Mongo drivers, you use everything from a Mongo tool. And the last thing before I actually hand it back to JP is I want to quickly show you another little tool which we are using when we are actually doing migrations in an offline manner. It's Mongo import, right? So I'm just loading an ND JSON file here, in that case coming out of the object store, into my Oracle database using the Mongo tool, right? And if you were now here, you see actually this is the AJD free database that I used with SQL as well. See, there is 3,800, and if I were to do a select count star here as well. And this is all actually backed up. It's the same Oracle database that you use for your relational world, that meaning everything starting, with transactional consistency over everything that has to do with high availability and disaster recovery that from the Oracle database is automatically preserved and used in the same way. I'm just seeing there were two questions. Let me actually quickly touch on them. The second one was, what will happen if the structure of the document changes on the future? Add and remove modified fields. Oh, JP, you're typing it, but I can quickly answer it live. It's a JSON document, right? So it doesn't matter. It does not matter what you're doing with it. There is no, at that point in time, if we're just talking about a JSON collection table, there is no schema enforcement in any way, shape, or form, right? If I have this table, you can insert any kind of, let's just use Mongo since we have it, since we can do it. Okay, refresh. There's my test collection, right? You are actually just inserting whatever you do. Now I have to find the right button. Insert document. So this is just a schema, and if you want to insert another record, right, you can do whatever structure you want, right? So obviously it has to be a valid JSON document, otherwise you will get an error, right? And so you have the full schema flexibility at that point in time. It's a JSON collection table. The only column, in a classical sense, is the physical container for the JSON collections. So you have the full flexibility that you have. And the other question, let's probably delay the question about primary key and foreign keys for a second. Just one comment. When we are purely dealing with a JSON world, right? A JSON document is always a hierarchical structure. So you're modeling your business object in a JSON document with a hierarchical endpoint, meaning that anything that you potentially have nested in your structure, like in these documents, in the arrays, if you're in a purely JSON world and you haven't modeled it, with, storing IDs, right? You're having redundant information about nested object and nested structures embedded in each and every document. But I will talk a little bit more about that a little later. I'm just getting too excited at that point in time, but it's probably best first giving it back to JP to actually continue the flow, because that question is tailored for the next second live session.
Indeed. So if you go to the next slide, we'll quickly wrap up this, because let's relate this to where we started again, right? Like, if we believe that data is critical for AI and we want to have a consolidated platform, nobody wants to use that platform unless we actually have the capabilities to really drive, for example, document workloads, right? And to model these documents and to store them and to retrieve them as fast or faster than, for example, a document database could do. And so hopefully this gives you some flavor of what we did, how we did put the document natively in the database. And hopefully this you'll walk away from this and go, well, if I need a document database and I have Oracle AI database, I already have one, right? And in a world where licenses cost money and where cloud consumption is real money, that cost proposition of having Oracle already and having a document store is a real key value proposition that we bring to the table. And so let's just go to the next section quickly. And it was kind of cool that the primary and foreign key question just came up, and it was a great transition to this section. So we'll talk about what's called JSON Relational Duality. It's something created and invented at Oracle, and we believe it's a paradigm shift in data platforms, right? It makes it even simpler to consolidate your data and to consolidate your platform, yet build all these apps and get all the benefits of relational and JSON without any compromises. And so let's go to the next slide. Right, Herman showed you create JSON collection table movies, right? And so we have a document database, it's fully supported. He showed you how document APIs and even other companies' tools just work on that because it's just a standard collection. Now let's talk about the bottom of the screen, right? Where we say create JSON duality view. And here we actually do something we think is very cool and we think is very topical to that whole data platform discussion. You'll define a duality view through SQL. But you now have read, write, delete access through both sides of the API world, if you think of it like that. I can insert through SQL, cool, but I can actually update a document through the document API as well. And let's talk a little bit more about how this is kind of working because we're separating storage and access, right? And so if you go to the next slide, Herman, and I just click one more so we don't have to do the build. So what really is going on here is that it's something you actually see also in data formats like Iceberg and like object stores and SQL on object stores and all of those things. What you start to see is that storage and access start to become split. Right? The cool thing that Herman talked about is that, and he talked about it in terms of redundant, right? But if you do a JSON document, all of the information that the application needs to show is right there, right? You do fetch this document and plunk, there it is. But it also means that you have redundant data, which is, okay, let's just for a second pretend storage is cheap. Okay, I have redundant data. The problem isn't so much the cost of the storage or like the bits on disk. It's the fact that it's redundant. If somebody updated it but didn't update the other copy, now which one is real, which one is true, right? So you get yourself into like data hell effectively. Relational enables you to do primary keys, foreign keys, do all of that wonderfulness. And so our storage format is a relational model, and that's your canonical form. You put it in that, you have all the access for SQL, but you have all of these capabilities of modeling this. And then what we enable you to do is not just read it through a JSON interface, but to actually make this look and behave like real documents. And so your application fetches the document, shows it to you, you make an update where we go from up to down, right? Or down to up, or whatever Herman did in his example. And you just do it on the application in the JSON world. And then the database reconciles this and makes sure that the translation is correct, that the exact values are updated, and we get rid of all of this redundancy. And this is tremendously powerful, right? Especially if you want to model a data platform that supports real-time AI that does all of these amazing things. This is going to get us there. And so if you go to the next slide, you really get the good and the good, right? like you've lost all downsides effectively, right? They're no longer applied, they no longer count. You have to think about them. What you really have here is all of the amazing things that application developers like of JSON and how we store it and data first, schema later, all of that good stuff. And all the use case flexibility and all of the declarative language pieces and all of the no data duplication consistencies guaranteed by the engine, not by the application. All of those come to bear. And if you go next slide, in this thing called JSON Relational Duality, right? So use case simplicity and tailored context of document/JSON, multi-use case, all of the cool things about primary keys and foreign keys of the relational database. And I'm going to take it to a live show so people can kind of see how this works, and then we can answer the PK and FK1 live as well.
Yeah. So he's gonna put me on the spot again. Okay, fine. That's what my neighbor always says. Okay, fine. That's his most common term. Let's probably quickly go back to the Mongo shell, right? I briefly touched on a couple of collections that we had added in addition to the movies and the little test that we did line, which is, the attendee schedule, session, and speaker, which is conceptually for you folks, that is a very simple data model, representing what happens in a conference that we quickly modeled in our Oracle database using JSON duality views. And what you will see here is you see these JSON collections attendees with a Peter and a Wendy, both living or working or residing in Neverland, which are actually having a schedule. Each of these people have a schedule. So Peter has a schedule where he actually attends, JSON and SQL. He attends a PL SQL or JavaScript and an Oracle on iPhone session, which is quite interesting, right? Conversely, on the Wendy side, we are seeing she's also in a PL SQL or JavaScript session, and what you see there from an object, from a conceptual JSON collection perspective, this is the collection that represents the schedule of Wendy, right? You see JavaScript is held by Helen. This is hopefully the same information that we have here for Peter. Yes, the session PL SQL or JavaScript is held by Helen. So you can guess what you're going to see if we click on speaker and on the speaker collection. We will see that there's at least one speaker, which is Helen, right? So this is when we are just looking at the business objects that our conference model is working in, which is basically you look at the same data from different angles. Who are the attendees? What is the schedules of those? Who are the speakers of the sessions, and ultimately the session catalog, right? These are the business objects you would have if you want to write a simple application that actually shows these things. So far, so good. Now, the thing is, if this is a purely JSON document-oriented model information, the information is redundantly stored in all of these different JSON collections. So the session has an information about the speaker Helen for PL SQL or JavaScript, as well as the schedule catalog, right? Which shows that there's PL SQL or JavaScript. So now, if I were to do this in a pure document store, whether this is MongoDB, whether this is Oracle JSON collection tables only doing anything like that, right? There would be the challenge that if Helen becomes sick and is replaced by JP as a presenter, right? You have to update this information in multiple places. You have to update it in the session catalog. You have to update it in the schedule. And you actually have to add a new speaker to it, right? So this is the thing that you have to do in a pure JSON collection world. And you would also have to ensure that, that if you add JP as a speaker, that actually JP is there as a speaker. Now, what you're seeing here at that point in time is not a pure JSON collection setup. These are duality views that I'm currently showing you, and before actually playing with them in Mongo, let me show you how they actually look like in the Oracle database, right? So we see we have these 4 views. We actually have more. Refresh, and when I look and I'm drilling down, let's just take the schedule. You know, you see that the oops, sorry, I picked the wrong window. The JSON collection schedule is actually modeled with an object document model that builds the document for the schedule based on the information of 4 relational tables. So there's the attendee, which is the root object, the root information, the attendee name. Actually, let me see what I can make that bigger. Okay. The attendee name, which actually has a relationship to the schedule, which has a schedule per attendee. So there's a relationship between these tables, and the schedule also draws in the information from the sessions and the speaker. So if we were to look at the SQL, how you actually model such a JSON relational duality view, basically the object document model in the database on top of the relational information that exists, looks as follows, and that is GraphQL syntax. It would look slightly more verbose when you use the JSON SQL operators, but it is reasonably straightforward to read, right? So the top level is an attendee, right? On that level, I can insert, update, and delete information where I'm extracting the information just out of an attendee name. And then based on an existing primary key, foreign key relationship at that point in time, we derive the information out of the schedule, where we then, for the schedule, which is basically a many-to-many table mapping between an attendee and sessions, because one or more attendees can attend one or more sessions. And then we get the session information out of the sessions table, the name, the location, the time, and the speaker information for a given session. So if you're looking at the document of a schedule, like we have seen it here, the schedule is, go back to schedule. This is a construct that is built on top of a relational model. Meaning that if I were to go back to my relational schema and I do select star from a speaker here, that is part of the relational duality view that we just looked at, the schedule, and the information about the speaker, Helen, is actually drawn out of that. So that means that there's 2 things to point out here. The first thing is that we completely remove the redundancy of storage of common attributes, meaning that the information about the speaker is only in the speaker table. You see there's no JSON collection table that has a schedule. And if I look into the schedule, you will see the information that you would expect in a relational schema as an intersection table for many-to-many information, which basically links the attendees to a session as a schedule entry, right? And when I look at session, attendee 1, and the session information, sessions. See, even with duality views, you have to actually ensure that you don't do any typos. You see the information about the sessions and the information where they're held and which speaker is doing that, right? It's also that we have these 4 simple tables, which is the foundation for the multi-use case of the JSON documents to look at the information of this data model from every different angle without the need of data duplication. So now we said, okay, Helen is sick and we want to have JP replacing her. And in fact, Helen is so sick that she's not going to the conference. But we actually make JP the speaker here in our conference management system, right? So now what happened? I updated the table speaker, right? If I were to go back and look at the speaker, you will see that Helen is no longer supporting our conference, but JP is the man. And what we automatically did, since the objects are the JSON collection, the JSON documents are built on top of this multi-use case model, is that the sooner I find the refresh button, you will see that at that very point in time, everything that Helen was giving before, which was not only the PL SQL or JavaScript, is updated in real time in my JSON collections. And you see, Wendy actually was doing the JavaScript as well. See, is also having the session held by JP. This is one of the big advantages of duality views, which gives you this duality to look at both and to ensure that you cannot violate the model or actually the information that is in there. So now probably one last comment before I move on. One of the questions is if you're building it on top of a relational model, are we tied to the fixed structure of a relational model? And the answer is no. Let's quickly look at the definition of the speaker view. And you see it maps to the relational structure of speaker, but it also has a field which I called other info, which is a flex field, which means that part of the schema, part of the relational schema is a JSON column, which is there to store any additional information that was not modeled into the schema initially, right? So if I were to go in there and let's just say JP, and I just want to add it, and I want to add another field, whatever, no, okay, nickname. Sorry, JP, I didn't. I'm allowed to do that. You will see I added something to my JSON document. So I have the JSON document flexibility. And when you see here is the information about additional attributes is actually stored and taken care of with that schema. And with that said, I think I'm talking too much anyways. I'm going to hand it back to you, JP, to wrap up and to answer any outstanding open questions live.
Yep, I don't think we have any outstanding questions so far, so let's just go here and
so
quickly
far
wrap
we've
it up.
covered everything. Yeah.
Yep, so let's quickly wrap it up, and hopefully you understand and got a notion of what a data platform should be doing. It should be powering your business and AI. And we've added, as Oracle, to Oracle AI Database, a ton of capabilities, right? You can look at them here. Herman showed you live what's going on there. If you go next slide. We also think that we can drive down the operational cost. We can simplify things, and we can allow and enable you to do a lot more with your platform just by hosting it on Oracle while supporting all of these key capabilities. If you go next slide. Now, if you don't believe us, then there's a number of customers who went through various journeys and moved off of kind of fragmented data stores, and they see very impactful business results. Right, you drive down cost, you get a whole bunch of interesting other benefits that come from this. And it's a pretty straightforward switch, right? No migration's ever easy, but we think we can do this quickly and efficiently. And so that kind of wraps up our content. So I'm going to hand it over to Ernesto, who can.
Thank you, Herman and JP, for an awesome session. We really appreciate your time and help, and I hope this was a good learning experience for everyone. Now on the screen, you see this want to learn more slide. Here you'll find a few links that will help you walk through Oracle Cloud, get some hands-on experience, some detailed documentation, our live lab website, and Oracle Learning Library on YouTube. And once again, you have access to this deck and links on our Day One and Beyond page, as well as Oracle Cloud Customer Connect. If you enjoyed this session and you would like us to conduct personalized training sessions for your organization, do email us at our personal training email and we will reach out to you. If you want us to conduct some hands-on um, labs, we have our quick shot live labs for a more expedited hands-on learning towards a particular topic. Under our developer experience program, we will help you co-develop a solution with you based on your own use case. And please remember that the personal training program is an investment we make in our customers to help them grow and develop their OCI skills at no extra cost to them. Here is our Day One and Beyond series and upcoming sessions for the month of February. You still have the opportunity to attend a couple more sessions this month within our hands-on series, our cloud security series, our core series, and Did You Know What's New in OCI? Now, if you enjoyed today's session, we do have a hands-on lab on February 10th here. That's going to feed into what you learned today, covering Oracle's MongoDB compatible API. Now, our next database session will be next month on March 2nd. Our database sessions are conducted every first Monday of the month at 10 a.m. Pacific Standard Time. And in this session, you will learn how to build AI agents with Oracle Database at Google Cloud and Vertex AI. So I hope you learned something new today. Thanks for joining today's session. I hope to see you on our next one. Hope you all have a wonderful day.